Hey guys, so today's flipped lesson is over 3.7 perpendicular lines in the coordinate plane. Go ahead and get your own sheet of paper ready for notes, or you can use the guided notes that are posted on the calendar. So, what do we know about perpendicular lines? Well, first of all, you guys need to know the symbol for perpendicular. Okay, it's an upside down capital T. Okay, we know that lines are perpendicular when they intersect at a right angle. When they intersect at a right angle. Okay, so what we're going to do is we're going to kind of investigate the slopes of perpendicular lines. So what I have this note card on a sheet of graph paper. Well, we know that all of those corners of this note card are 90, 90, 90, and 90. Okay, so we know that we have these right angles. So I would know that if I call this point A, point B, and point, I'm going to call this point right here C. I know that in this picture that AB is perpendicular to AC, right? Because they are meeting at a right angle. So now what we're going to do is we're going to find the slope of line AB. Well, remember, slope is rise over run. So we rise 1, we go up 1, and we run 1, 2, 3, 4, 5. So we rose 1 and ran 5. So it looks like this slope is positive 1/5. Now let's take a look at the other slope, the slope of line AC. Well, again, it's going to be rise over run. Okay, so we're going to go down 1, 2, 3, 4, 5. Okay, we're going down 5, and then we're going over 1. So rise is down 5, run is positive 1. Well, let's take a look at these two numbers. What relationship occurs? Do you guys see how basically these are opposite reciprocals? So I'm going to write that word down and then explain it. Opposite reciprocals. They are both flipped and the sign has changed. Okay, so you flip the fraction and you change the sign. So the slopes of perpendicular lines are always going to be opposite reciprocals. Okay, the last thing that I do want to share, just because this relationship will always hold, notice if I multiply 1/5 times -5 over 1, let's see what happens. When you multiply fractions, you do numerator times numerator, right? Top times top. So -1 times positive 1 times -5 is going to be -5. Then on the bottom, you do denominator times denominator. 5 times 1 is 5. Well, that simplifies to -1. Okay, so one way to check to see if they're opposite reciprocals is when you multiply them, they should be -1. Or you can just make note of the fact that they are flipped and the sign has been changed. Okay, so let's put this down in your notes formally. This is a postulate. Okay, the slopes of perpendicular lines. What do we know about them? In a coordinate plane, if two non-vertical lines are perpendicular, or they are perpendicular if and only if, okay, the slopes are opposite reciprocals. Which means, right, those slopes are flipped and negated. That's what it means by opposite reciprocals. Or, okay, your other option for this, in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So product is multiply. So that's another way, okay, to check to see if the slopes are opposite reciprocals. Now, we need to talk about vertical and horizontal lines that are perpendicular. So the slopes of vertical lines, if we're referring to vertical, okay, then vertical lines, right, if you think about a treadmill, have an undefined slope. Okay, so then the line perpendicular to an undefined slope would be a slope of 0. Okay, so undefined slopes and 0 slopes are always going to be perpendicular. So that's for vertical and horizontal. Okay, vertical and horizontal lines are going to be perpendicular. So that would look like this in the situation, vertical and horizontal. So undefined slope versus a 0 slope. Think about treadmills with those. Okay, so now let's just go ahead and practice these ideas, deciding whether lines are perpendicular. Okay, so what we're going to do is we're going to find the slope of J1. So let's find the slope of J1. So for J1, it looks like we are going to go down 2 over 3. So we went down 2 over 3. I'll do it in a different color just so you can see it. Down 2 over 3. So that's how I got our rise over run. Now let's talk about J2. Okay, for J2, I'm going to erase those markings. It looks like we are going to go up 1, 2, 3, 4, 5, 6, up 6, over 1, 2, 3, 4. So my rise was 6, my run was 4. We can simplify this to be 3 over 2. Okay, so now let's take a look at this slope versus this slope. Are they opposite reciprocals? Are they flipped and has the sign changed? Well, I'm going to say yes, they have. Okay, another way to verify that they're opposite reciprocals is you multiply these together. Negative 2/3 times 3/2. Okay, numerator times numerator. So negative 2 times 3 is negative 6. 3 times 2 in the denominator is positive 6. So that is indeed negative 1. So I'm going to make the claim that J1 is perpendicular to J2. Okay, because their slopes are opposite reciprocals. All right, let's take a look at another example. Decide whether these are perpendicular. I'm going to name this line X and this one line Y, just so I can kind of talk about them a little bit more easily. Let's find the slope of line X. Okay, it's going to be rise over run. So we're going to go down 1, 2, 3. So down 3 over 1, 2, 3, 4, 5, 6. Okay, so it looks like down 3 over 6, which that would simplify to negative 1/2. Okay, let's clear the screen. Let's take a look at another one. We're going to find the slope of line Y. So it looks like we are going to go up 1, 2, 3, 4, 5, 6. So we went up 6 and we ran 1, 2, 3. We ran 3, so that is 6 over 3. Rise is 6, run is 3. Well, that would be 2 over 1. Well, now let's decide. Are those opposite reciprocals? And I'm going to say yes, they are. They're flipped and negated. Another way to check that they're opposite reciprocals is to multiply them together and see if we get negative 1. Negative 1 times 2 is negative 2. 2 times 1 is 2. And indeed, we are getting negative 1. So my conclusion is I could say X is parallel to Y in this case. Okay, or I guess I could have said that segment BD is parallel to segment CA. That's another way I could have represented that. And that's because the slopes are opposite reciprocals. So that is a right angle. Okay, let's look at a different situation. Deciding whether these lines are perpendicular. Is line H perpendicular to line J? Well, let's look at these slopes. This one has a slope of 3/4. Okay, line J has a slope of negative 4/3. Well, let's multiply those together. 3 times negative 4 is negative 12. 4 times 3 is positive 12. So that's giving us negative 1. So yes, okay, H is perpendicular to J because their slopes are opposite reciprocals. All right, nice job with that one. Let's take a look at this situation. Okay, now notice these are not in the form y equals mx plus b right now. It has to be in this form if I'm going to identify what the slope is. So I have to put it in that form, which means we need to solve for y. So let's start with line R. I'm going to subtract 4x on both sides. If I subtract 4x on both sides, I'm now dealing with this situation. Okay, so I subtracted 4x on the left, subtracted 4x on the right. Now I'm going to divide by 5. So you're going to divide the first term by 5. That would be negative 4/5 x plus, and then also this term divided by 5 plus 2/5. All right, now let's repeat that process, but for the other line, so for line S. So I'm going to first subtract the 5x over. And let's divide by 4 now. So y equals negative 5/4 x plus 3 over 4. Okay, you got to divide both terms by 4. Now we can investigate for a second. Here's the slope of this line. Here's the slope of that line. Are those opposite reciprocals? They are not. They're flipped, but the sign has not changed. So I'm going to make the claim that R is not perpendicular, okay, to S. Another way to put the term not is to put a slash through this. So you can say not perpendicular. So you can either write it out or you can use the symbol by putting an X or a slash through the symbol for perpendicular, okay? All right, last practice question that we're going to do for this video. Line L has an equation of y equals negative 2x plus 1. Find an equation of line 2 that passes through that point but is perpendicular to line 1. Okay, first it's telling us to find the slope. Well, here's the deal. If it's going to be perpendicular, then the slope needs to be the opposite reciprocal. Well, what's the opposite reciprocal of negative 2? You can think about negative 2 as being over the number 1 if that's helpful, but let's flip it and negate it. If you flip it, now 1's on top and 2's on bottom. And if you change the sign, it's now positive. So this is the opposite reciprocal of negative 2, positive 1/2. So now, so far, we know that y equals 1/2 x plus b. Well, now I'm stuck trying to find my b value. Well, I know it goes through this coordinate. I know it goes through that xy. So let's plug it in. It goes through that point. Now let's solve for b. Well, 1/2 times 4 is 2. So 0 equals 2 plus b. Subtract 2. So I'm getting that the y-intercept is negative 2. So my final answer is y equals 1/2 x minus 2. This would be perpendicular to line 1, and it's going to pass through this given point. All right, guys, that brings us to the end of our video. Let's just discuss what you need to do at this point. You're going to watch, you already watched, and hopefully you took notes on this flipped lesson. Now you're going to upload your notes to Showbie just to show to me that you are actually watching the video and taking notes. And then once you're done uploading your notes to Showbie, just move on to this final step. Okay, attempt the practice problems that go along with this information and bring your questions to class tomorrow. All right? Good luck with the rest of your homework. I will see you Tuesday.